Welcome everybody to Saving Your Wallet from the Cloud. My name is Kevin Feasel. I am a data platform MVP out of Durham, North Carolina, where I run a predictive analytics team. I also have a blog called Curated SQL. The idea of Curated SQL is I try to find and link to 5 to 10 interesting posts per day on topics all across the data platform space. So check that out at curatedsql.com. What I want to do over the next roughly 1 hour is to give you an idea of cloud pricing models, specifically using Microsoft Azure for examples. And I want to give you an idea of ways in which you're able to maybe migrate an application to a cloud service or to use cloud services without going bankrupt in the process. Because click the wrong things, scale it out the wrong way, and things get a lot more expensive than they need to be and can be much more expensive than on premises. So I'll have some advice trying to help you along and ensure that you're getting the best bang for the buck. As a quick note, I do assume that you have enough experience in Azure that you're able to deploy resources, you have some solid understanding of what infrastructure as a service is versus platform as a service, how they differ. If you don't know any of that stuff, I have a companion talk called Getting Stuck in the Cloud, and I'm going to drop a link in here in case you want to check that out later on. So now, let's talk a little bit about what pricing looks like in the cloud. And cloud providers typically use what is a pay-for-use model, and generally it's billing you monthly. When you buy something on premises, usually you pay up front, you get the thing, and depending on what you've purchased, that's the one thing that you pay for. There are, of course, subscription services. You license Windows, you license SQL Server, especially if you have software assurance. So there are ongoing billing options on premises, but when you move into Azure, pretty much everything is ongoing billing. And this is even more the case when we move from renting virtual machines to running things like serverless applications, function applications. My analogy is we're actually moving closer and closer to what the old mainframe days looked like, where you rented CPU time. And we're kind of getting back to that point, because if you think about a service like Azure Functions, you're paying directly for compute time. So you're not really paying to rent a VM. There's no fixed price per month. It's strictly consumption based. So everything old is new again. The pay-per-use model is an example of an operating expenditures billing model, which pretty most commonly known as OpEx. On-premises hosting is typically financed using a different model called CapEx, capital expenditures. And this is probably the best time in your life for us to talk about CapEx versus OpEx, I think. So let's get into this a little bit. The idea behind capital expenditures is I'm buying a fixed asset. I'm buying a large piece of machinery that is going to help me generate this product, or I'm buying a building in which I can have people work and generate my product. Or I'm buying a truck that I will use to haul my goods across the country. These are usually measured as things that are going to stick around for a very long while. You don't buy pencils as a capital expenditure. They just replace them. You do buy trucks as a capital expenditure. We expect this to run over multiple years. And the big benefit to capital expenditures is, in that little parentheses note, at least one tax year. The idea here is if I pay, say, $600,000 for a combine or a harvester, then I can stretch that over the useful life of the product, maybe 20, 30 years. So if it's a $600,000 combine over 30 years, I get to depreciate that product over the 30 years and basically have the tax burden carried over for that whole time, which generally gives me a positive impact on my future taxes. It lets me have more predictable, more scheduled tax burdens over the course of the lifetime of a product. By contrast, operating expenditures, these are going to be for things like daily operating expenses. I need pencils, I need paper, I need something that maybe I'm going to use it up. It's not going to last me for years and years and years. The longevity for this means it's all put in the same tax year. If I buy $150,000 worth of paper, that's all being, it's all an expense for this current year. It's not something that I can depreciate over 5 years unless you have an accountant who finds a way to do that for you. But if you treat it as an operating expense, then it's within the same tax year. So I cannot depreciate, I cannot amortize. Why I might want to use capital expenditures versus operating expenditures. There are a couple of reasons why you may want to use both of them. On the capital expenditure side, there's this little thing at the bottom called EBITDA. And EBITDA is very popular among startups, among, say, early revenue companies, and among companies that have just recently gone public. And what it stands for is earnings before interest, taxes, depreciation, and amortization, EBITDA. So basically, it's your earnings, and you subtract out anything that's, well, depreciated or amortized. What that means is all of your capital expenditures are things that you depreciate or you amortize. You get to remove those from EBITDA, and the revenue that you have earned stays in there. With operating expenditures, you don't get to remove them. There's in EBITDA, and the more operating expenditures you have, the lower that EBITDA figure is. On the market, EBITDA tends to be a measure that a lot of analysts look at, even more than earnings or price to earning ratio, especially for smaller firms. So this may actually have a negative impact on how analysts view your company if you switch from having heavy capital expenditures to having heavy operating expenditures. On the opposite side, capital expenditures usually involve a lot of negotiation, a lot of going to the board, of planning out 3-year, 5-year, 7 years, because that's the depreciation period or the amortization period, depending on what you're buying. And that means, for example, if I buy servers that are intended to last for 5 years, and Intel or AMD comes out with a new line of chips that are 50% faster than my current servers, I kind of have to suck it up or go back to the board and try to get them to finance another capital expenditure. Companies can get around this by buying percentages, refreshing a percentage of their server pool every year. But there comes a limit to how much you can switch out. Essentially, if this thing's going to last me for 5 years, for tax purposes, I kind of have to keep it around for 5 years. And we don't want to buy another thing that's going to be really expensive during that period if we can avoid it. By contrast with operating expenditures, I'm essentially paying an ongoing subscription. I'm paying ongoing current fees, which means if I want to switch over to something else, it's as easy as saying, I'm done paying for this, I will pay for this other thing instead. So summarizing some of the differences here, capital expenditures is typically harder to push through and get that budgeted. They tend to be larger expenses, and it can be a risk if hardware that you're purchasing immediately goes obsolete. If you've made a poor decision, that can hurt you a lot more. By contrast, operating expenditures, better for single business decision makers, somebody like a CIO or a CTO, someone who has a budget. Approval and spending is a lot more flexible, but if you have too much in operating expenditures, it can affect the bottom line for analysts. If you talk to Microsoft people, they will try to sell you on just how easy operating expenditures are. Oh, this is OpEx, not CapEx, and treat it like this is something that is unalloyed good. But there are major benefits to CapEx, especially for companies that are able to make their cash flow, their tax burden equalized over the course of several years. And Daryl mentions cash flow has a negative effect up front on CapEx, CapEx has a negative cash flow effect. So yes, that is a good point. This is an area where I know just enough to be dangerous. But I do want to point out that if you talk to a Microsoft person, if you talk to an AWS person or Google or any cloud provider, they will push you hard on OpEx and talk about just how easy it is. It's just add a credit card and bam, now you're billing. There are still benefits to CapEx. When it comes to cloud providers, everything's got a price. If you want to bring data into them, that's actually, usually it's free. And at the extreme, if you have an enormous amount of data, Microsoft will ship you drives. They will ship you hard drives. You can load up the hard drives, you ship them back. They'll even pay for the shipping. Getting your data out, now you pay. So Hotel California, you can go in for free. You're not getting out otherwise. You want to, oh, by the way, yeah, it's free to put that data in there, but if you actually want to have it stay in there, you got to pay for that. You want to use that data, well, you have to pay for the compute to actually process any data. And of course, you have to pay for network utilization. I mean, that's not free, especially if you have network utilization transiting between different regions. That's certainly not free. If you want high availability, you want to make sure that your data is actually available when you need it, but you usually have to pay a little bit extra for that. Oh, if you want things faster, you can pay more for that too. You can usually always pay more money to get something. And if you're running this in a dev or test environment, you kind of have to pay. There are some services that are free, that have free tiers, but most services, you're going to pay something. Is this a current and accurate summary for a variety of Azure cloud services? Yep. Like I said, we'll talk about where dev and test can be cheaper or it can be free, but generally, almost every service, as soon as you're in, you're paying for all of these different categories. And we'll see where some of this pricing comes from and how you can calculate that over the course of the talk tonight. But really the short version is Azure has a pricing calculator. That pricing calculator is actually really good. AWS has a pricing calculator. It is pretty good. I like Azure's pricing calculator a lot, except that you kind of have to understand how the calculator works to get to understand how the calculator works. It's sort of pretty complex to get started with. And we'll try to disambiguate it a little bit tonight as well. So how much is my stuff going to cost? I mean, that is kind of the ultimate question. Well, as I mentioned, the pricing calculator, which if you've not been to this site before, is a very useful site. You will have your cloud solutions architects at Microsoft. They will use this calculator. The salespeople will use the calculator. Microsoft partners, so third-party companies, organizations that work with customers to help land them on Azure, will use this calculator. Not everything is in the calculator. For example, if you say, I want to have Power BI for my employees, Power BI is not included in this pricing calculator. There is no option to say, I want to enable Power BI premium SKUs, or I want to have premium per user. There's nothing in there for Microsoft 365. There are a lot of Microsoft cloud services that are not part of the Azure pricing calculator. So your total expenditure might actually be higher depending on what you want to do and essentially what services you wish to have. This includes everything which is in Azure itself, and Power BI Online, M365, that kind of stuff. even though it is tied very closely in with the Azure world, not everything in there is, strictly speaking, Azure itself. Also, if there's anything which is currently in a public preview or a private preview, that will not show up in the pricing calculator. So things that are in preview in Azure are free. When Azure Synapse Analytics was in preview, that was free. Now that it is generally available, you have to pay for it. There was a stretch of time where Synapse was still public preview, but was close to going GA. And if you went to the Azure Synapse Analytics page in Azure, it would tell you what the pricing would look like, but that data wasn't in the pricing calculator yet. Does it increase as soon as it becomes public? Yes, basically as soon as a product is generally available, then they're going to start billing. They will alert you if you're in a preview program. They will alert you and say, as of February 1st or March 1st or whatever date, we will start billing for this. So it's not something that just happens overnight. They will give you usually 4 to 8 weeks of lead time to say, this is coming up. We are going to start charging you. Here is the pricing page to show you exactly what that pricing looks like. While it's in preview, usually early in the preview, they don't even talk about pricing. Late in the preview, they'll finally announce the prices and give you a few weeks to decide, do you want to keep using that service? Another thing to keep in mind throughout this is if you do a migration, don't forget the cost of migration itself. If I have an on-premises application that I wish to move into Azure, it's not as easy as click a button, everything's up there. There is a cost to setting everything up, and that setting everything up means things like ensuring that you've got Azure Active Directory set up, that you may have Active Directory to Azure AD synchronization, that you've got the services set up, configured, that your application can deploy out. Even if you're going from on-premises VMware-based virtual machines to virtual machines in Azure, and you're just doing a straight copy over, there's still a process of testing, of setting up networks, making sure everything is right. For small applications, that price could be anywhere from about $5,000 to $15,000 per application. Large apps, you could be talking $500,000 or $1 million or more for the process of migration. And think of that as, even if it's your team doing the work, this is the opportunity cost of the other work that you could have been doing while you were doing this testing, this migration, assuring that everything's working, configuration, and so on. So even if you don't hire a consultant to do that work, think of it as the cost of what you could have been doing otherwise. So big question, is the cloud cheaper than on-premises? And the short answer is a hard maybe. My shorter answer is probably not. So if you're in a really expensive data center, then public cloud can be cheaper. But it has to be really expensive. If you do have extreme hardware requirements, then probably not going to be cheaper. Once you're at a point where you're talking about thousands of servers, if you're at a point where you can negotiate serious discounts with vendors, you're not really going to save any money in the cloud, not usually. That said, even then, the answer is kind of maybe, but my default would be if you're normally getting that 30-40% discount from a company like an HP, you're not going to get that same value. If you just take a virtual machine, like I mentioned, I have VMware virtual machines on premises, I'm going to take them and put them into Azure. If you do that, you are almost definitely paying more money. And if you have data in multiple geographic regions, this is an area where you could potentially be saving money by moving into a service like Azure. So for example, if I have MongoDB clustered across a bunch of different geographical regions, it might be less expensive switching to Cosmos DB. But even if it is cheaper, usually it's going to take some time. It's going to take some money to optimize your solution and make it most efficient for a cloud service. The way that the cloud works, the assumptions that applications based on cloud services have are different than what we have on premises. As a quick example, on premises, we usually pretend that the network is always available and that the network is never too slow, that it's fairly stable, almost never drops packets, and is always at a relatively static speed. In cloud, none of those assumptions are viable. We have to assume that there will be network failures. We have to assume that there will be service outages, that there will be different times at different times of the day or different days of the year. We may have significantly different latency. We may have different paths that we need to negotiate to get to those servers. And latency is measured more in milliseconds than in microseconds, like it would be on an internal network. So there are built-in differences that we're going to have to understand and pattern our applications around. But that's maybe a talk. That's a slightly different talk getting into that topic. Here, we're about saving money. I'm about maximizing the savings. So how do we maximize the savings? Well, one method that we could potentially use is called reserved capacity. So Azure typically has about 3 models for pricing. One is pay-as-you-go or pay-go. Another one is that you reserve some capacity for 1 year. And the third option is you reserve capacity for 3 years. Typically, if you reserve capacity for 1 year, it's about 30 to 40% less expensive than if you just went pay as you go for a full year. If you do 3-year reservation, it's anywhere from about 50 to 70% less expensive. Pretty big savings. And you may look at this and say, well, why would you ever do anything other than 3-year reservations? So let's talk about that. Why would I choose PayGo? Well, if you use a service less than about 30 or 40% of the time, it's going to be cheaper than that 3-year reservation. As an example, if I have a data warehouse that is only used Monday through Friday, 9 to 5, and I can shut it off during off hours, I'm actually going to save money by not reserving capacity. When you reserve capacity, it is reserved for 100% of the time. So that 50 to 70% off, that's 50 to 70% off having it run 100% of the time, 24/7, 365 and a quarter days a year. So if I don't run it that often, I'm probably going to save money by sticking to pay as you go. If I just want to try out a service, there's no way I'm going to recommend reserving an instance until you have a really good idea of whether you're going to use a service. Because if I reserve this thing, I have to pay for it for a year. So if we're not going to use it, that's a waste of money. Definitely start out as pay as you go. If you want the lowest upfront price, typically pay as you go has no down payments. For a 1-year reservation, for a 3-year reservation, you have the option of having a down payment where I may pay 20 or 30% now and then pay a regular rate for that 1 year or for that 3 years. On the other side, pay as you go never has prepayments. Now, if you can fit everything into inexpensive tiers, if you're fairly small, you have a small application, small databases, pay as you go is often cheaper than reserved instances, especially for certain services. Azure Blob Storage, for example, there is reserved capacity, but that reserved capacity is usually measured in dozens or hundreds of terabytes or even petabytes. So if you don't have petabytes worth of data in Azure Blob Storage, reserved capacity is way outpriced. If you have, by contrast, a virtual machine, VMs, definitely something that if I intend to have it run for a while, I would want to reserve. Another tip on reservation is quite often if you have a scale out service, let's say you're using something like Azure Synapse Analytics, you may want to reserve a percentage of your total capacity. So for example, Azure Synapse Analytics dedicated SQL pools use a model called DWUs, Data Warehousing Units. And DWUs scale out roughly linearly. They're also priced roughly linearly. If I have, say 10,000 or 12,000 DWUs. So let's say I'm at 12,000 DWUs, but sometimes I scale it down, sometimes I scale it up. I may only want to reserve maybe 9,000 DWU. And that way I have some ability to scale down. And in those cases, I can save a bit of money. If I have to scale it back out, then yes, I'll pay a little bit extra, but on net, if I have it scaled down more often than not, I will end up saving cash there. So if you have a 1 or a 3 year reserved instance, you get the discount described, but what happens if the pricing drops during that time? Does your price also drop corresponding with that? Short answer, no. Long answer, no, but. No, but if you talk to your rep, then usually, especially if you renew that reservation, then they'll give you the lower price. So for example, let's say that I'm 1 year into a 3 year reservation and the price of a virtual machine drops by 30%. I don't get that 30% discount. If I just go on and don't pay attention, I'm paying the 3 year reservation price that whole time. And in fact, there have been times on both AWS and Azure where pay-as-you-go over a 3 year period has been cheaper than a 3 year reservation for exactly that reason, that as new hardware comes in, the old hardware gets less expensive. So if you are on a reserved instance, it's still worthwhile to check it out every 6 months or so, just to make sure prices haven't changed considerably. And if they have, talk to that rep, because if you're, like I said, 1 year in, you could have a 3 year reservation and sort of have a new reservation, and they'll give you the lower rate. So they tend to be kind of flexible about this stuff. Also, if you have a 3 year reservation and you say, I need a larger virtual machine, they'll allow you to break that current reservation and create a new one. They'll also sometimes, depending on who your rep is and what your relationship is with them, will also let you scale it down. If you say, I bought big, but now that we've done some optimization, we don't need anything near this size, they'll also let you break it to scale it down. But this is something where the better relationship that you have with your Azure person, the better off you're going to be. And considering I have zero, I don't work for Microsoft, I don't make any of the decisions there, and I'm just some random dude on the internet. In that regard, this is definitely something that you would want to discuss with your rep. All right. So I think that gives you an idea that pay-as-you-go is worthwhile. So we say pay-as-you-go in these cases, 3 year reserved in other cases. Why in the world would I want to do a 1 year reservation? Well, before I get to that, obviously we know 3 year reservation makes a lot of sense if I have this service up 100% of the time, and if I'm making a 3 year commitment. Also, going back to that CapEx, something really interesting in the world of accounting. That is not even a misnomer. We talked about capital expenditures and operating expenditures. And I mentioned that capital expenditures are things that you can amortize over the course of multiple years. operating expenditures, you got to take it all in the same tax year. Well, when you have cloud services, originally, everything was OpEx, literally everything. You have a 3-year reservation and you paid 100% up front. That's all OpEx. That's all on this year. But as of a few years ago, GAAP rules have changed to where specific things can be amortized as capital expenditures if you have a multi-year reservation. So the cost of software that you're licensing, that SQL Server, that Windows Server, those things, you can amortize that if you have a multi-year deal. For a virtual machine, it's still a little fuzzy. The information that I have, my understanding is that the VM hardware itself in a 3-year deal can be amortized at this point, but that this idea is pretty new. There's still a lot of debate going on inside the accounting regulatory bodies, the groups that come up with the generally accepted accounting principles, and they are moving kind of slowly on what constitutes capital expenditures with the cloud. But they're definitely moving in that direction for longer term deals. If it's a 1-year deal, still in the same tax year. Always move slow. Yeah, they do deliberately. They're very deliberate. You don't want to jump and make a really bad decision because everybody's going to ride that thing forever. So I get why they move slowly. Just something to keep in mind. All right, 3 years. 3 years sounds pretty good. And mind you, not everything, even if you have a 3-year reservation, not everything can necessarily be depreciated like that or amortized. So 1 year. Why would I ever choose a 1-year reservation? Well, actually, it turns out 1 year tends to be better than 3-year in a lot of cases. If you don't consider the CapEx portion of this, if you don't consider the tax implications of this, quite often, like Mark was alluding to, the prices of things like virtual machines tends to drop over time. New hardware comes out. When that new hardware comes out, the Gen 5 hardware or the Gen 6 hardware, the prices of previous generation stuff goes down. Usually the newest stuff stays at about the same price. So if I paid $2.45 per hour for this much RAM and this many virtual CPUs, on the newer generation of hardware for the same amount of RAM, same number of CPUs, it's going to be about the same price. Meanwhile, the older generation might see a 20, 30% discount, may see a 50% discount. So given that VM prices tend to drop over time, it could make more sense to have 3 1-year reservations rather than 1 3-year reservation. And Nick mentions UAT or training environments. That's another good example. If you have a case where maybe you don't expect a thing to survive for 3 years, or you can't guarantee that this service will be around 3 years from now, that you may not need that virtual machine or that Azure Synapse Analytics dedicated SQL pool or that Cosmos DB reserved capacity. If you're not positive that you're going to need it for 3 years, keeping it for 1 year is a good trade-off that gives you some flexibility and also lets you jump on price drops if they come up. Something that if you're currently on premises and you have software assurance, you may not be familiar with is called hybrid benefit. The idea of Azure hybrid benefit is that you can use on-premises licensed versions of certain software in Azure. Windows, SQL Server, Red Hat, SUSE Linux. If you have those licenses on premises, you can use it in a virtual machine in Azure for specific purposes. So let's talk SQL Server in particular. You can use hybrid benefit to migrate your on-premises SQL Server into an Azure VM, or into Azure SQL Database or Azure SQL Managed Instance if you want platform as a service instead of infrastructure as a service. Now, you can use the license in one of the two places, but there is this 180-day grace period for concurrent use where you're migrating. The intent is I'm going to migrate from on-premises into Azure, and I need 6 months. You get 6 months to do that work, during which time you can use the license in both places. But once that 6 months is over, then you have to shut down or buy a new license for your on-premises stuff. So if you are planning a migration, you can use hybrid benefit to save a fair amount of money when you're migrating up to Azure. And for installing a VM that has SQL Server is literally a checkbox or a radio button where you ask, do you have hybrid benefit? Yes. Now, when you talk to your licensing person and when they do their licensing audit of your company, that's where they'll true up. They'll make sure that you have all of the licenses that you say you do, and they will check your Azure and your on-premises solutions, and they'll have a pretty good idea if you're not correct. And if you are not correct, you're going to pay for licenses to true up or shut down those servers. So UAT and testing environments. Let's talk a little bit about dev and test, because if you're specifically building services that are not intended for production, there are places where you can save some money. If you're using a Visual Studio subscription, you can create something that's called a dev test subscription. In this dev test subscription, you will get development or test pricing, which means that licensing costs go away. So when you're licensing SQL Server or you're licensing Windows Server, Red Hat Enterprise, SUSE Enterprise, or, well, CentOS is RIP CentOS, but at this point, Windows becomes as inexpensive as Ubuntu. You don't pay for that licensing, so the hardware price is the only price that you're paying. And it also provides discounts for a service like Azure Application Services. Even for platform as a service offerings, you can get discounted prices for those services if you're using a dev test subscription, and that is part of Visual Studio licensing. Of course, only for dev and test environments, so can't use it for anything that's production work. But something to keep in mind. A lot of companies I know have basically they put their dev stuff in the same subscription as prod, and they're paying full price for dev and for prod when you don't really need to. So check that out. If you do have Visual Studio licensing, if you have paid for that, then you are eligible for dev test subscriptions. I recommend reading into that some more, and it may be a way to save some cash. Now, another method that you can use, a little bit easier, is just to use free tiers or development grade tiers. There are some services that have free tiers. For example, Azure IoT Hub has a free tier. It's something like 8,000 messages per day. It's not very many messages, but if you have a sensor, if you're doing something for home usage, maybe you're tracking humidity levels in your house, then you figure if I have 8,000 messages per day, if I send one per minute, well, that's 1,440 per day. So I could have several sensors and still be under those limits. There are other products that do have free tiers. Azure Application Services, if I remember right, still has a free tier. Azure SQL Database does not have a free tier, but they do have a basic tier, which is $5 to $15 a month. So even for services that don't have free tiers, quite often you'll see a basic tier that is intended really for development or for single person usage for demonstration purposes. It's usually going to be slower. It's usually not going to have high availability, and the service level agreement is probably going to be a little bit a fair amount lower. So instead of getting 5 nines, it might be 3 nines, something along those lines. And if you do talk to Microsoft folks and you ask them, how do I save money in Azure? And when I say Microsoft reps, every time I say that, assume I also mean AWS, Google, Alibaba, Tencent, whoever you're using for cloud services. They're all going to talk about the magic of scaling. That if you scale up or scale out for specific requirements, then you can scale back down when you don't need the compute. Scaling down does work pretty well in dev environments or in environments like that data warehouse I talked about where it can run 9 to 5 and we don't need it afterwards. But frankly, a lot of use cases for companies that I've worked at and with, we don't really have applications that can go down after 5 p.m. Things have to be up all the time, and traffic happens overnight. So this is somewhere that I don't think you get nearly as much bang for the buck as the sales reps will intimate by giving you the option of scaling down. At the extreme, yeah, if I'm able to shut off services for periods of time, then sure, I can save some money. But generally, if it's got to be running, I can't really turn it off. I might be able to scale it down, but even then, there's still a cost to scaling down. That cost is not dollars. That cost is time and uptime. Scale down will take time. And if depending on the service, that scale down could affect customers. So if I scale down a SQL database, whether that be a dedicated SQL pool in Azure Synapse Analytics or Azure SQL Database or a virtual machine running at a SQL Server, that's going to essentially block any access to the database while the scale down is occurring. During that time, you're not getting any work done. So that's not going to be great. For things like application services or websites, where you're scaling out more than you're scaling up, scaling back in is usually fine. Websites and application services are a perfect example of having floating scale, where maybe during the day you can scale out to 5 or 10 instances, and then as the load drops, it scales back down to 2 or 3, and then as load picks back up, it can scale back up. So you can control that level of scaling out and in. Up and down usually is going to involve blocking, usually is going to involve downtime. You may be at a minimum for scaling. You can't go below 1. So that if you're at that bottom rung already, there's nowhere to go. Also, I would highly recommend against changing tiers when you're scaling. So what do I mean by this? Within Azure, there tend to be 3 different tiers: your basic, standard, and premium. Depending on the service, they may call them different things, but usually you could think of it as basic for developers, for demos, for playing around. Standard for development for small environments. Premium, more of business critical or needing faster response times or better high availability or disaster recovery answers. And those are sort of your mental starting points. For each service, the specifics of what's included in each will differ, but that's the thing that I start with. So if I move from premium to standard, there are things that I lose. If I regularly use those things, like for example, if there's some automated backup service, or if I have to move from premium disk to standard disk, yes, it's cheaper, but it's also a lot slower. And it can take a lot of time to switch between the sets of disk. So even if it is possible, usually it's a really bad idea unless it's a permanent one-time change because I no longer need these premium features. Scale down, generally not the best solution. Instead, I recommend cloud native development. This is a set of principles and practices that will help build applications that work better in public clouds. So let's talk about what each one of these principles represents. First, microservices. Small, independent, constrained services that do one thing really well and communicate with each other. They take information, they do a thing, probably they output results. Often they're connected together. They can run on really small virtual machines, they can run in containers, they could run on Kubernetes, and sometimes you can host multiple microservices on the same instance. There are extremes where if every application is a microservice and you have tens of thousands of microservices all communicating, that's a tricky situation of its own. And we could have discussions about the limits of where microservices should go. But as a principle, this tends to work better for cloud services because I can get a tighter control. You know, when you buy on-premises servers, I buy so much compute because I expect that I'm going to need this much compute 5 years from now. So I over purchase today in the expectation that I'm going to grow into it. And therefore, if our on-premises servers are running at 20% CPU load, we're happy with that. Like, hey, it means I have plenty of compute left. If you're in the cloud and your services are running at 20% compute load, you should be unhappy with that because you're paying for 100% of that compute, but you're only using 20% of it. So you want, in an ideal world, if you didn't have to worry about things like thrashing, you'd want to use 100% of your resources. That's ideal world. Real world, you definitely want to have overhead because we'll have spikes, we'll have increases, we'll have different patterns that necessitate more resource utilization at certain points of time. So maybe we want to be 60, 70, 75% of capacity. We definitely don't want to be down in that 20% range where we're happy on premises because we're paying for all of that extra resource. And when you're building out microservices and you're deploying them on tiny VMs, B1, B1S, or in AWS like T2 Micro, then you're putting out basically the bare minimum amount of resource that you could possibly use for this and scaling it to the right size, but not higher than that. And if you need more later on, you can scale it up. Along with microservices, I want to talk about event-driven development. So microservices receive information, handle requests as they're received. This is asynchronous. This handles really well things like network outages. Oh, I'm not able to access this other service for a 10-minute period. That's okay. I'm not going to fail. I'm just going to wait until I get a new message. If we keep those services independent, we can scale them independently. We can make sure that we've correctly sized each one of these services separately from the others. So if I need more processors on one particular part of the equation and I don't need it on the rest of them, I can scale those independent of the others. And this is also a case where I might be able to shut off some services overnight. There may be some processing work that really can be turned off overnight, but other things stay on. So there's an opportunity for savings or for more fine-grained understanding of how things work. I already mentioned overhead, so we want to minimize that overhead. We want to run usually about 65 to 75% hot. Don't go above that because the closer you get to 100%, the more likely things are just going to stop working. and you definitely want to have some level of overhead capacity. For some services like Cosmos DB, they have built in the notion of burstiness, where if I have 5,000 request units that I've pre-purchased, and I have a minute of 10,000 request units, they're actually okay with that. They will support that with the idea that after that minute or so, we're dropping below 5,000 for a little while, so that if you smooth it out, we're within that 5,000. If you're consistently at 10,000, they will start throttling you down to 5,000. So they have rules built in that will contain you to that RU limit, but will allow you to burst if you stay under. There are also virtual machines that allow for burstiness, where maybe 90% of the day is really quiet, but then there's a short burst where we need twice as much compute, and then we can give it back up later. And those are burstable instances. They're specifically named, they're specifically lettered in both AWS and in Azure. One thing that I think developers like is this gives you an idea of aggressively hunting technical debt. It can be difficult on premises to get the business side to understand the importance of fixing technical debt. Usually the only lever we have as developers is to say, well, this is slowing down my development. If I fixed this thing, then I could deliver 8% faster, and you'll get this much more in terms of stories. Which for a business analyst or for a product manager, they have to weigh against all the different requests from end users, requests from corporate management, basically from the people who are in other stakeholders who are really important in the success of a project. So developers usually get the short end of the technical debt stick. But in the cloud, certain types of tech debt, if I have, say, data that's never been archived, or if I have slow processes, things that are inefficient, this is literally costing the company money. Now I can say, if we do this archival project, moving this data from very expensive storage in Azure SQL database, premium storage on SSD, to glacial storage or cold tier storage in Azure Blob Storage, we're looking at a price difference of this many tens of thousands of dollars per month. Now you have technical debt measured in terms of ROI, in terms of dollars that you're going to be able to sell to the product manager and usually have a better chance of getting particular projects run. As a quick example of this, my team has some services that are running in a cloud. Actually, we're using AWS, not Azure, but same principles. And we were spending probably about $2,000 a month on one particular service. We got an opportunity to really change the way the service runs, make it a lot more efficient, and cut down the price to like $300 a month. So you can see major changes just from making an application more efficient that have real differences to the bottom line. One other way to impact the bottom line, I mentioned that virtual machines tend to be pretty expensive in Azure, and they're pretty expensive in AWS. I would say, look for ways to get away from virtual machines. Platform as a service offerings and serverless offerings, if done efficiently, can be less expensive than equivalent VMs. So those tend to be some of the most price-effective services if you've developed that microservice style, if you're using event-driven architectures for development, and you're really hunting down unnecessary overhead and technical debt. You cut all of that stuff down, serverless-based or platform as a service-based applications can end up being a fair amount cheaper than the equivalents if you're just hosting virtual machines. So most likely what I've described is nothing like what you have on premises, and that's fine. The the rules around on-prem development are different than cloud development. The benefits that are in place, the incentives that are in place are significantly different on-prem versus in the cloud. And that doesn't mean don't move to the cloud, and it doesn't mean your developers were dumb. It means the incentives are very different. And if you do say, I need to move to Azure or to AWS or whoever, then you will want to think about not only how do we migrate our current applications, but how do we develop them in a way that minimizes the long-term cost to the company. And how we can do that, starting with smaller product offerings. Don't try to move everything up all at once, because that's going to lead you to, we have this project, we have 30 applications to move, and we have 6 months to do it. All right, we'll take the VMs and just dump them in Azure. So going lift and shift like that is fast, but it's expensive. Spend some time and look for how can we make this faster, cheaper, and less resource intensive. Removing external dependencies, removing access patterns that are very time consuming or that expect 100% constant immediate uptime. Optimizing code and database performance. In Azure SQL database, bad queries can cost you money. If you're looking at the serverless SQL pool in Azure Synapse Analytics, data processed is $5 per terabyte of data processed. That means if I have 100 terabytes of data and I scan through that 100 terabytes of data, that is $500 on my bill. If I only needed to scan 1 gigabyte of data, rewriting that query saves me literally hundreds of dollars every time I run that query. Obviously, if you run the query pretty frequently, it adds up really fast. So this is a case where it's easy to put dollar amounts on tech debt cleanup and on performance efficiency. And don't forget bandwidth. That is going to cost you money as well. I also recommend checking out cloud architectures because they are going to differ from what is on premises. And what is good about Azure, one of the nice things about them is that there is the Azure Architecture Center. And this is a site that has a bunch of different architecture patterns for specifically developing in Azure. So spend some time looking through that. There may be something that is fairly similar to a product that you're interested in moving or that you've already moved, and you can compare against to see what differences in decisions that are possible here. One example of those is the Scalable Web Application. And the idea is I want to have everything from the actual web application. So, actually I want to draw, not zoom it. So the web app itself using Azure App Services, which is using a queue for that event-driven architecture to call a serverless function app. That serverless function app is going to retrieve data from some storage, whether that be Azure SQL Database, Cosmos DB, whatever. We're going to store it in a Redis cache to pull that back faster the next time, and possibly make this database smaller as a result because there are going to be fewer calls to that database, so it doesn't have to be as powerful. We're storing more data in here. Also getting static content cached in Azure Blob Storage, which is really cheap. It's a few pennies per gigabyte per month. And using Azure Content Delivery Network to distribute that data across the world, making it fast for people to access it. And also Azure CDN is really cheap as well. Having this combination of services, I want to show you just how much of a difference few pricing choices could make. And we'll do the really simple versions because I know that we are getting at that 1 hour point. So I probably have to log back in. Oh, there we go. Okay, web application. So I'm going to open up the initial one And I'm also going to open up the minimalist one. And just to give you a rough idea, initial version is about $15,000 a month, looking at this architecture diagram and implementing it. So not including some services, but about 15 grand a month. Minimalist, I can get it down to 6,600 a month, and I lose some stuff, but you can make an argument about whether you really need it. So cognitive services, I included that because we have Azure Search down here. And the Azure Search is for things like product catalog lookups. Cosmos DB, if we use pay-as-you-go, 4,000 RUs, these numbers, I kind of pulled them out of a hat thinking about what a realistic, moderate to large sized web application could use, but they're still pulled out of a hat. So about $200 some a month. Azure SQL Database, we've got 3 instances in an availability zone and 8 cores, pay as you go for everything. About $6 grand a month, plus all storage, et cetera, et cetera. Azure Cache for Redis, I said, let's go enterprise because, you know, enterprise sounds like it's really, really good. Enterprise Flash sounds even better. That sounds really fast, but it's almost $2 grand a month. Azure Functions, I said, all right, 512 megabytes of memory, take half a second, and we've got a lot of execution. This is a very busy website. And then about 10 terabytes of data storage, yada, yada. There are some app services in here as well. So 2 cores, 7 gigs of RAM, 250 gigs of storage, 6 of those running 100% of the time. $1,700 a month. Azure Front Door is, think of that as routing for those app services and also web application firewall. So it's a useful service, very useful service. Couple $100 a month for roughly 750 gigs of outbound data transfer. Our CDN is like $184 a month. We're doing it over Verizon, standard tier. And Azure DNS, couple $100 a month. We've got 2 DNS zones, 500 million DNS queries a month. Azure AD costs a bit of money. I said I have 100 users and I'm premium. I'm paying good money for people. So by contrast, this is $15,000 a month. If I come back up and look at the minimalist solution, so where we say, if I can find efficiencies, I can end up saving a lot of money. So for example, with cognitive search, I actually, looks like I kept it the same. Oh, nope, I did drop it actually quite a bit. So what did I do? I went from standard S2 to standard S1. Standard S2 and standard S1 are for Azure Search are going to make a pretty big difference. But if you don't have an enormous amount of data that you're searching through, then S1 may still suit you. So here's a case where if I'm able to say, I don't really need S2, I can get by with that performance tier of S1, significant difference in price. Cutting the Cosmos DB in half. My assumption here is if I aggressively cache, I don't need as much database access. So the harder I can cache, the better I can do with caching, the better off I am in cutting down services that are really expensive, like Azure SQL Database. So here I went to 1 business critical with a 1-year reservation, ended up saving, going from, you know what, I can't even remember at this point how much the Azure SQL Database was, but if I, okay, 6 grand down to about 2 grand. So I went to a higher tier from general purpose to business critical and fewer cores, 8 down to 4, with the assumption that, again, I'm aggressively caching and I don't necessarily need as much. And then also saving a fair amount of money. So about $300 per month. You can see here, 1983 to about 1672 by doing a 1-year reservation. If I happen to have Azure Hybrid Benefit, that actually saves me a lot of money per month as well. This is where Hybrid Benefit can be very good for you pricing wise. I did trick you a little bit with enterprise tier versus premium tier in Redis caching. Enterprise tier is essentially you get a server, and there are some features in enterprise that are for Redis as a database versus Redis as a raw caching service. If I drop down to premium tier and use 1-year reserved instance, I can save a good $1,500 a month. So this is where playing with the pricing calculator, really understanding what the tiers mean and finding what is the most appropriate tier and level for my environment, you can get a good feeling for what price differences look like between different solutions. So how we can save money if we're building a web app like this, cache. I mentioned cache because that way you can scale down databases. CDNs are really cheap. It was like $180 some a month for global distribution of all of my contents like JavaScript, like images, HTML files, things that are static, things that don't really change. You could scale if you experience bursty behavior. The areas where scale makes the most sense in the diagram here is really in this app service. So you could scale this up and down as you need it. Otherwise, function apps are consumption-based. Redis and your databases, you typically don't want to scale. Azure Search is something that you might even get rid of in this scenario. If you're really price conscious, I might drop Azure Search altogether and not have that product catalog. But if I assume that I really want to have an Elasticsearch-like searching capability, Azure Search is useful there. The more that you can cut down, the faster you can make your product, the less money you're going to pay. The less compute you use, the less compute you pay for. Especially if you have, if you don't oversize your machines, if you don't overexpand your expectations on how much compute you require. Find out how much you actually need, scale down to that level, or give yourself some overhead, just not an enormous amount. And that's a good way to cut down on pricing. It's a different mindset than on-prem, where I need to know what it's going to look like several years from now. So overbuying makes a lot of sense. Here, overbuying just costs you a lot of money. Last thing I want to talk about, a little bit about budgeting and alerting. So in Azure Cost Management, you can select budgets. What a budget will do is let you know when you've reached a certain level of spend for your entire subscription or for a subscription group. I can create a budget, maybe that says, oh, I'm going to budget for $106. So if I hit that $106 or so, I want an alert. Oh, sorry, $101. As soon as I hit $101, I want an alert. And what that alert's going to do is send a message to you. It can send an email and contact maybe an accounting group, maybe an internal business unit, could hit the manager. So if you have subscriptions per business unit, you could email the manager of the business unit and say, hey, you've hit 90% of your monthly capacity. You might want to slow your roll a little bit. Or you're at at $5,000 a month. Please review what you've got. Make sure that all of your services are running, that are running are necessary, and see if there is any scaling or improvement that you can do. So I can send these to alert recipients, and also even do it on forecasting. So if I forecast and the budget looks like it's going to hit above a certain amount, then I can send an alert. So in October here, we can see what the forecast looks like. I haven't hit that 85% yet, but it looks like I'm going to go over it. So let's send an alert and say, hey, you're at 85% of your budget, and it looks like you're going to go over. So might want to investigate what's happening here. Those cost alerts will also show up in the Azure portal. You can set them up as emails. You can also review them in the portal and reach certain levels of spend for that account. So it could be at a department level, it can be on the subscription level, and give you a little bit of granularity there. The last thing here, spending limits. If you're using Azure credits, you will have a spending limit each month. So for example, if you have a Visual Studio based account, you may get $50 of Azure credits. You can have those Azure services running. And if you're under $50 at the end of the month, everything's fine. You lose the credits, but that's okay. As soon as you hit $50 of spend, your service is shut off, unless you click a little button to remove your spending limit. If you remove your spending limit, you associate with a credit card, and now you're paying. If you have a regular Azure account, you cannot set a custom spending limit. So credits don't roll over. No, they do not. So if you have a $50 a month credit, it's $50 every month, but you don't have any rollover of unused credits. So you cannot set up custom spending limits, which I wish they would let you do. Yeah, if you have a paid account, there's no spending limit. It's however much the bill is. And I'd really like to be able to say, yeah, I'm willing to pay $30 a month or $120 a month or $7,000 a month, but don't let me go over that amount. Cannot do that in a regular account. The only way you can do it is if you're using Azure credits instead of regular billing. If you're in a large scenario like a multi-client or for a large company, chargeback can be really important. Easiest way to handle chargeback is usually by tagging resources. So ensure that all of the resources have appropriate tags for maybe your cost center or business unit. And that way you can use Azure Cost Management to figure out what the expenses look like per business unit for chargeback purposes. This is something that you have to manage yourself. There is no Azure rule that will automatically charge this business unit this amount of money based off of what they're using within a subscription. The closest thing you have to that is payment methods per subscription. So if the marketing department has a subscription and engineering has a subscription and HR has a subscription, they could use different payment methods to cover their subscriptions. But there's nothing that would say, I have one Azure subscription and I have 12 clients and I do a chargeback model for them. They're not going to auto charge those 12 clients. You can use the cost manager to figure out how much to charge them as long as you've tagged those resources. If you have a resource that is across all of those clients, there's no really easy way to track percentage utilization. So like if I have a SQL server that's covering all 12 clients, there's no real easy way for me to say client 1 has 8% of CPU utilization, so therefore I'm going to charge them 8% of the cost of the SQL server. That's something that you could potentially build yourself, but nothing built into Azure, AWS, or any other cloud service. So, all right. Over the course of tonight, we have looked at the billing model for the cloud, including OpEx versus CapEx. We looked at the Azure Pricing Calculator. Now, I highly recommend take some time, play around with it. And we looked at some strategies to save money in the cloud, helping save upwards of 60% off of a naive bill if we really, really cut out the fat. We made some assumptions in this, but you can see significant savings. If you want to learn more, if you'd like to grab these slides, or if you want to get links to additional resources, that is all at csmore.info/on/wallet. If you have any questions at all afterwards, please do feel free to reach out to me. Here is my email address, and I want to give you my Twitter handle as well for all the good that does. So with that, does anybody have any questions?
Thank you. That was awesome. I'm going to play around more with the pricing calculator for your recommendation. I always kind of knew it was there, but never really got my hands too dirty. We're looking at a Dataverse versus Data Lake plus Azure SQL kind of scenario. Any recommendations for us? I mean, and not long term, but just things to consider or whatever, taking your temperature and yeah, just thoughts, I guess.
Yeah. So my short answer is probably you're probably going to end up with a yes and situation rather than a either or, because Dataverse is really helpful for integrating with Power Apps.
Yeah.
But as soon as you want to do any sort of real longer term analytics on that, you probably want to take it out of Dataverse and put it into a data lake.
Just due to the costing associated with running that through Dataverse, or the performance benefits of Data Lake?
More the performance benefits and also the available tooling.
Gotcha.
There's still a lot that can't natively access Dataverse. It's really well suited for Power Apps, for Logic apps, for Power BI, that whole Power Platform area.
Yep.
But it's a lot less suited for say web applications or any sort of data science activity, any sort of analysis activity.
We have our ops engineering team going, HD Insights and Spark and the whole bit, and then the application services side is going full Power Platform, ERP, CRM. Yeah, so you're right. Yes, and.
Yeah, and there are data lakes tend not to be that expensive in Azure. You get to the pricing of the lake itself is really good, and the serverless SQL pool is priced, I think, really well if you write efficient queries.
Yeah.
Dedicated SQL pool is a little expensive, well, a lot expensive, but if you're talking HD Insight, that's an expensive product too.
Yeah. Oh, but this is really good. Thank you so much.